Hey there, guys. Mr. Catlin here with lesson number 7's homework problems and trying to get you some help if you're struggling. Decide whether each table could represent a proportional relationship. If the relationship could be proportional, what would the constant of proportionality be? So in lesson number 7, we start to look at relationships and trying to decide if they're proportional or not. Okay. Everything we've done so far, we're assuming that it's proportional. Now we have to decide if it is or not. And then if it is, if it has what its constant of proportionality is. All right, so let's go to the first one here. How loud a sound is depending on how far you are away. And a way to check for proportionality is you should have a constant number that can be multiplied by all of the numbers on the left to get all of the numbers on the right. Or one way that we've attacked this is we take another extra column over here and we divide all of one of the quantities, let's say dBs, by all of the feet, and we see if it gets the same ratio or not once we divide it. So for example, to test this one out, you could do 85 divided by 85 divided by 5, and then 79 divided by 10. And right there from the get-go, this was 17 and this was 7.9. We do not have a match, so we would say this one is not proportional. Now, if all of those quotients would have come out the same number, then we would know that it is proportional. And sometimes you can look at it and get an idea, but other times you have to just go through and check. This time I'm going to take the money and divide by the ounces and see if I get the same ratio each time that I do it. So this particular one, I'm going to do $1.49, and I'm going to divide by 16. And then see how it gives me this 0.093125. Let's see if I keep getting that amount or not. $1.59 divided by 20. Different. Okay, so this one right here was 0.093. And this was like 0.07 and some change. All right, that tells me that it is not proportional. Just because there's a pattern in the table, like this is going up 10 cents and this one went up 30 cents. Okay, just because there's a pattern of how things are growing doesn't necessarily mean that it's proportional. We got to check it by testing all of the ratios of the two quantities. All right, so let's go on to number 2. Number 2 says a taxi service charges $1 for the first tenth of a mile and then 10 cents for each additional tenth of a mile after that. Fill the table with the missing information, then determine if this relationship between distance traveled and price of the trip is a proportional relationship. Okay, so you have to pay $1 to ride. Okay, taxi for $1 for the first tenth of a mile, and then 10 cents for each additional tenth of a mile after that. Okay, so for this one right here, the first tenth of a mile would cost you $1, right? So $1 plus you've got 8 more tenths coming up. So, all right, so 8 tenths is 10 cents a piece. That's 80 more cents. So this first one is going to cost us $1.80. Okay, the second one here, you get 2 full miles. So the first tenth of a mile is going to cost you that $1. Plus, after, think about it, 2, if you take away a tenth from it, that's going to be 1 9/10. So you still got 1 times 10 plus 9. You still got 19 tenths to pay for. That's 19 times that you're going to be paying a dime. So that's 19 times or $1.90 more cents. So this one would be $2.90 for that ride. All right. This tenth here cost you the $1, and then you got 3 more holes, which, you know, you're paying a dime for every tenth. That's 3 more dollars. So this one would be $4 even. And then for the 10 miles, all right, you're going to pay $1 for that first one, and then you've got 9 9/10 miles left, and that's 99 dimes. Okay, 99 dimes is $9.90. Plus the extra dollar for just riding the first tenth of a mile, that's $10.90. Okay, you see how I filled out the table? I had to do a little bit of math and add that extra dollar. The question is, though, is this relationship between these things proportional? And we can test it out really quick. Okay, we can test it out by seeing if there's a constant between these two. So if I do 10.9 divided by 10, that gives me, actually, I'll make a little table over here. I'll do dollars divided by miles. Okay, dollars divided by miles. So if I take the dollars, $10.90, and divide by 10, that would give me 1.09. That's that ratio. Let's do another easy one. Let's do 2.9 divided by 2. If I cut $2.90 in half and I divide it in half, that would be $1.45. These are not equal. So since they're not equal, then I can say that this is not a proportional relationship. Not proportional. And we prove that through filling out the table and testing to see if all of the relationships were proportional or not. I'm beginning to wonder if we're going to have any that are proportional, because every one of them so far has not been. Let's look at the last set of problems on the very back page. All right, for lesson 7. All right, this one has a couple of tables for us to check out, and it wants to know about this rabbit and this turtle and their distance and time relationships. Is the relationship between distance traveled and time proportional for either? If so, write an equation that represents the relationship. Okay, let's start with the turtle. Okay, we'll start with the turtle, and I'm going to add just a little column here for the turtle. All right, and I'm going to have that as minutes divided by meters, okay, or time divided by distance. All right, actually, let's do it the other way around because it'll come out a lot nicer. Let's do distance divided by time. That'll come out a lot nicer. 108 divided in half would be 54. Okay, 540 divided by 10 is 54. This is starting to look like it could happen. So we need to test out those other ones, right? 405. And we divide that by 7.5. This is looking like it's going to be 54. Okay, so we got to test one more just to be safe. 1768 and a half. Turtle, slow and steady, winning the race, right? It's slow and steady because it has a constant of proportionality. Now, if you remember the story, the rabbit was not that way. Let's see if remember the rabbit will do, like, he's going to go really slow and then try to kick it up later, right? Or go really fast and then take a break and then maybe fall asleep. I don't remember the story exactly, but I've got a feeling that the rabbit is not going to be a constant speed. It's not going to be proportional. So let's do distance divided by time for him. 800 divided by 1 is 800. 900 divided by 5 is not 800. I can go ahead and say that this is not going to be proportional. Divided by 5. Okay, so 180. So we can stop there. We know that the rabbit is not moving at a constant rate like the turtle is. Constant, slow, steady turtle. All right, rabbit, we don't even know what these are going to be. We don't have to. This one is not proportional. All right, but we do know that the turtle is proportional, and we can write an equation for the turtle. We know that we can multiply the time times our constant of 54, and it will give us the distance that the turtle goes. So an equation for that, it says to write an equation. The equation for that would be, we're going to take t's and multiply by 54. That looks like this, and that will give us what the distance equals, d. And there we go. So that one's finished. Let's look at the next set, number 4. For each table, answer, what is the constant of proportionality? Okay, so we're assuming that all of these are proportional. So our constant is going to be from left to right, left to right, left to right. So we're all on the same page. We're not going to give the constant that comes back right to left unless we're asked to write 2 equations. Okay, so the first one's pretty easy. The constant here is 7, right? Because they're multiplying by 7 to get from side to side. So this one's answer is 7. This one here, 3 times something to give us 360. We can divide. This is going to be 120, I believe, but let's divide to make sure. Yes, so 120 is what they're multiplying by. So 120 is our constant there. Okay. Now, this is the first time we have a constant that makes it smaller. So I'm anticipating a number that is less than 1 here. We're going to do 3 divided by 75 to find that out. Now, I'm dividing those top numbers just because they came first. Okay. 0.04. Okay. That's what I'm multiplying to get over there. Now, yes, 25 is a popular answer here, but it's not the constant that gets us from A to B. All right. Our constant of proportionality here is 4 hundredths, or I will also accept 1 over 25. Okay. And then lastly, to get from 4 to 10, 6 to 15, 22, and so on and so forth, we have to divide 10 and 4 to find that answer. So 10 divided by 4, that gives us 2.5. So we know that since our multiplier from left to right is 2.5, that is also our constant of proportionality. And there we go. There's your homework. It's finished. You can take a breather, and good luck on your test on Friday.